All right. Hey, everyone. My name's David, and welcome to the fifth Hack.py workshop. This workshop, we're going to be going over how to work with data. So before you get started, if you're watching the recording, download Anaconda Navigator. We'll be using Anaconda Navigator's Jupyter Notebooks feature for our code. And also, if you guys are live at the workshop, be sure to check in with the code data hack. Won't be doing any hacking, unfortunately, but that is the check-in code. Yeah, so here's a little title slide. And if you guys need a link to the slides.
That is correct.
What's up? Okay, I think that was a accident on mute. But anyway, yeah, that's linked to the slides if you guys want to pull them up. It's going to be more hands-on for this workshop, so we will be looking at the slides a little bit, but for the most part, I'm going to be doing some live coding that we'll be going over. All right, so to start off with, what is data? So data is essentially just information, right? You can get data from nearly anything. So in like technical terms, data is usually like some sort of qualitative or quantitative thing. It can be like something describing something else. It can be like numerical. Data is really just any form of information. So data is really valuable because with information, you can discover things and draw conclusions and stuff like that. So nowadays, when social media companies and all these companies are collecting a ton of data, it's really valuable to have because they can use it to draw conclusions and better improve their own apps. So I gave some examples of where data science is used. These are all big tech companies, but I'll go into a few examples of like how data is used on these websites. So for example, with like Instagram, when you go to your Explorer page, how do you think they know exactly like what you want to look at? So if you have a bunch of memes on your Instagram Explorer page, for example, it's probably because you look at a lot of memes and Instagram took all that data and said, okay, we want to show this guy memes because he really likes memes. With Spotify, for example, if you've used the Discover Weekly feature, it will recommend you like new songs. They recommend you songs based off of your listening history. So if you listen to a lot of like one genre, one artist, it uses its algorithms to basically see, okay, well, if this guy listens to a lot of this guy, maybe he'll also like this related artist as well. TikTok is basically all just data science. That's how they recommend videos to you. They basically see what trends you like and what videos you look at the most. And they're going to be like, okay, well, if he watches a lot of Charlie D'Amelio, he probably likes a lot of like TikTok dancing videos or something. I don't really watch TikTok dancers, but I assume if you watch a lot of that, you'll probably get that recommended to you. And then, basically all these companies use data science, but it's not just tech. The medical industry uses data science a lot to find, for example, like medical issues, I guess, in someone. Like they'll analyze people's bodies and see, oh, like these bodies have this pattern here. We can find there's an issue here because we have all this data. So data is super valuable, essentially. So what does the data science process really look like? Well, there's a lot of different ways you can analyze data, but here's just a few steps of like how data scientists usually follow a procedure and when they're working with data. The first step would be like acquiring the data. So before you can actually do anything with data, you have to actually find data you want to work with. There's a lot of different ways you can find data, and we'll go into that in a few slides. After that, you have to explore the data. So when you get data, you have a bunch of numbers or you have a lot of information basically, but to really find something interesting out of that data takes some time and some research. So that kind of leads us into the next step of analyzing the data and forming a hypothesis. So when you have data, you want to see, okay, what can I draw from this data? What can I conclude? What do I think will be the result of analyzing this pattern in this data? So you really want to make a prediction, and then after you make that prediction, you can begin analyzing it and seeing, okay, is this prediction correct? After that, you want to like clean the data and actually test whether or not your idea is correct. So this is the part where you open up pandas and you start breaking down the data and creating visualizations and doing all that to figure out whether or not your idea is correct. And then optionally, like I know a lot of data scientists will use machine learning to build models. So this is usually used for like predictions. All these like big social media companies I mentioned before all train models to predict the actions of users. We're not going to be going into that in this workshop just because it's a bit out of the scope, but that's a common thing that data scientists will do. And then they'll also create visualizations and draw conclusions based off of the data they have. So if you have a hypothesis and you want to validate the hypothesis, you have to be able to show someone that like, oh, this is actually what's happening here. Like this is a pattern that I realized. And visualizations are a really good way to get that across. All right, so for this workshop, basically what we're going to be doing is going through the process of those steps on a data set. To start off with, we're going to go through step 1. So that would be acquiring the data. So data is everywhere. You can get data from a lot of different sources. I listed a few of them here. So you can get it from the Google dataset search. So for example, if you want to find data on like cats, there's probably some random data set on cats, the number of cats in the US, cats per square kilometer, cat data set. I just thought of this on the spot, but this is such an interesting data set. Someone has a data set on cats per square kilometer. That's very interesting. But yeah, you can, with Google dataset search, it's a really powerful tool for just finding tons of data sets. You see Kaggle comes up a lot. I think I list Kaggle here as well. Kaggle has a ton of data sets on a variety of different things. And they have like competitions as well to see like who can analyze these data sets and draw certain conclusions from them. So Kaggle is also a really good resource. I can pull that up really quick just to show you guys what exactly Kaggle is. We have a chat. Yes, cats, yes. So yeah, they even have a tab for data sets where you can explore different types of data. So Netflix movies, all of Trump's Twitter insults, all this fascinating data that you have right at your fingertips. And then you can also compete with others if you want to go into competition. Usually it's like training some sort of machine learning model that works really efficiently. If data science is your thing, then Kaggle is definitely a really good resource for you to check out. And then it's also data.gov. So the government publishes a lot of data with their taxpayer money. So if you want to go and find government data, this is very useful, especially if you're interested in like politics or just stuff that our government agencies collect. So yeah, a ton of random stuff on here, but definitely can draw some useful conclusions. And then more locally, we also have the San Diego Open Data Portal. So this is the website we're actually going to be using for our workshop. San Diego publishes a lot of data, which is really cool because I don't think many cities give this opportunity, I guess, for people to go through the city's data. So for example, they have all these public data sets like parking meter revenue, street repair work, water testing results, street sweeping, budget data. Basically, all of this data is public to you. So if you go to browse data, they even have it sorted by categories. So if you're interested in, one sort of category, for example, if you want to look at economic data in San Diego, you can find all that here, zoning data, police data, public utilities, all that. So that's all available to you if you just go to data.sandiego.gov. So yeah, as a data scientist in the field, you'll probably actually get this data from your employer. So when you're hired as a data scientist, companies usually want you to draw some sort of conclusion from the data they have and help it make the company revenue in the end. So usually that's what's going to happen. They'll give you some sort of information. You'll have to draw conclusions. But the first step is just getting that data in the first place. And then it's also important to, ask questions when you look at a data set because, you'll have this data, but what you can actually draw from it may not be super obvious at first glance. So in this case, the data set I want to take a look at is actually San Diego police data. So let's see if I can find it here. Based off of traffic collisions. So this data set's really interesting, and I think it has a little preview here, but there's a bunch of different things in this data set. And I think go to the next slide first. So yeah, we're going to explore the data. This is the second step of the process. We're going to take a look at what we have available to us. So these are basically thousands of reports that San Diego police took for traffic collisions. So this is when one car runs into another car. Looks like it's basically only car collisions. So basically just a bunch of people that are bad drivers in one data set. Fun. We got information like the report ID, the time it happened, the police beat. So police beat took me a little bit to understand what this is, but each of these are codes for different areas in San Diego. So each of these correspond to a specific area. It'll tell you like the address, the street, violation type, the description of the charge, and then how many injuries or deaths there were. And also like what kind of crime it was. So if it was a misdemeanor, I think they also like felonies in here or something, but anyway, this is like a bunch of information, and just looking at this, like this is a lot to look at. I'm pretty sure you don't need all this information to actually draw conclusions from this data set. For example, I don't really think that having the report ID is super useful for figuring something out in this data set. I think for me, the most important things would probably be like, where did these accidents happen? Which is something they give you, like what kind of accident was it? How many people died? How many injuries were there? This is like important information that's part of this data set. Maybe like the description can be important to you. It really depends on what you're trying to do. But before I go on, I actually want to ask you guys what you think would be something cool you can draw from this data set. Because I already know what I can draw from this data set, but I'm curious in like what you guys think could possibly be taken from just this data. I'll give you guys a minute to figure that out. High accident locations, density of accidents. Yeah, definitely. So yeah, because they tell you the location of like where these data sets are, you can actually figure out like where most of these accidents are happening, which is cool. Common type of accidents, true. So I think, yeah, if you look at the chart descriptions, you can see like what kind of accidents there are. So like this looks like a DUI, hazardous violations, like basic speed violations. You can see like what kind of laws people are breaking the most. So yeah, this is all like important information you can draw from this data set. So for our example, one thing I want to look at is specifically like what areas in San Diego are the most dangerous to drive through. So we have the police beats, right? The locations of where these accidents happen. And then another thing we have is like how many injuries are there? How many people were killed in these accidents? So knowing this, you can actually lump together all of these locations and see, okay, what areas in San Diego are actually the most dangerous to be in terms of like driving, like which area in San Diego has the worst drivers. So this comes to our hypothesis, right? Like our hypothesis is that like this area has the most amount of accidents in San Diego. We have our question like, what area would it be? But like, what's our hypothesis? We have to figure that out. So I also want to ask you guys, what area do you guys think is the most dangerous to drive through in San Diego? Because when I first looked at this data set, I actually was new to San Diego and I didn't really know what part of San Diego would be the most dangerous. But when I looked at this data set and I ran through all the steps, I figured out, oh, like I didn't even expect this area to be the most dangerous, but it kind of makes sense. So Thomas says South San Diego. Does anyone else have any other ideas of where in San Diego there could be the worst drivers? But nothing can be worse than LA. True. I feel like drivers in San Diego are probably pretty good. Well, maybe. I don't know. For my East Coast experiences, I think that West Coast drivers are just not as good, but I suppose I'm a little bit biased. All right. So yeah, South San Diego is one idea. So yeah, that's like our hypothesis, right? Like we think that South San Diego would be like dangerous. I think when I first looked at this, I thought like maybe downtown would be the most dangerous, in the middle of the city. Because I don't know, I figured there's a lot of drivers there, so there's probably a lot of accidents. But yeah, we'll go into that with this data set. So yeah, the next step after we explore the data is to actually analyze the data and draw a hypothesis, form a hypothesis. So we already did that. We said our hypothesis, for example, we'll just say our hypothesis is that South San Diego is the most dangerous area in San Diego to drive through. And then we already kind of took a look at the data, like what information you might need. So that would be like injuries, deaths, and where the accidents may have happened. But right now we only have that number, right? So we're gonna have to do more than just look at that number. And then next, we're gonna actually work on cleaning the data and testing a hypothesis. So we wanna actually take this data and clean it and then try to find some information from it. We can do this with the pandas library. So if you guys haven't heard of pandas before, it's a powerful I'm reluctant to say easy to use data analysis library for Python. I wouldn't say it's like super easy to use, but it's the best option there is. I think data analysis in general is not the most intuitive thing to do, but Pandas is a really powerful library that lets you do basically everything you need with data analysis. So if you download Jupyter Notebooks, you should already have Pandas installed. And yeah, so once you do that, I'll have you guys open up a Jupyter Notebook. So let me move zoom around. If you go to Anaconda Navigator, search it up. It's not working because I just re-downloaded it. Applications. Okay, yeah. Open up Anaconda Navigator. It takes a second to load. And then it'll bring you to this page. It'll probably ask you to install Jupyter Notebooks. But if you already have it installed, you can just launch it. What this will do is it'll launch a server for you and then bring you to your root directory, right? So we're going to start off with creating a new folder. I'm going to call this folder, I don't know what I'll call this folder. I'll just call it, let's go with Untitled folder for now, because I don't really think it matters what the name is. And you can create a new notebook. So you just go to new and then click Python 3. If it says like Python 2, it should be fine too. I think everything that we're doing should also hopefully work with Python 2, but no guarantees there. Oh, I got my tax return back. Nice. Anyway, once you do that, the first thing you want to do is import pandas. So we'll be using the pandas library. You can do import pandas as PD. PD is just a little abbreviation we'll be using instead of typing out pandas every time. So do that. And then after we do that, we want to actually load in our data. So if we go back to the website, the traffic collision data set, you can see there's actually an option to download the CSV file. So they have resources. You can get a dictionary, which I think if you preview this, the dictionary just shows what all this information means. So police beat, basically you can see there's also another linked data set to this that we'll be looking at later. But it kind of describes all of the information. All we really need right now, though, is the CSV file for the traffic collisions. So once you download that, you can open it up. Karen's birthday. Oh, God. Okay. Create a spreadsheet, I guess. It's not my goal, but anyway, I just want to take a quick look at the data to show just how extensive it is, really. But yeah, this data set has all the traffic collisions from 2015 up to now. So I think they've been maintaining this website since around 2015. They've been procedurally updating this with new information. I actually think that when I first looked at this data set, it was a couple of years ago. The results have changed a little bit since then. So they're keeping it pretty updated. But yeah, as you can see, there's like thousands of rows. I think like looks like maybe even more than 100,000 rows of just like police data. So it's really crazy how extensive all of this is, and it's super detailed. You could really draw a lot of cool conclusions from just this data set. Yeah, wow, it looks like over like 200,000 rows. Anyway, exit out of that. We want to load this data set into our Jupyter Notebook. So if you go to your downloads, and I'm just going to copy paste this information into where I launched my Jupyter Notebook, which is in my documents. Wow, my directory is kind of a mess right now. Developer, Untitled folder, there we go. So you want to make sure it's in the same directory as your notebook so you can actually use it. Cool, so once you do that, you can actually load in the file. So I'm going to make a variable called traffic data, and we'll be using pandas to read in the CSV file. And so we can do that with doing read CSV. And what this does is it'll convert a CSV file into a pandas data frame. A pandas data frame is basically just a loaded table that is built into pandas, and it lets you do a lot of manipulations with that data. It's just pandas like inherent table type that lets you do modifications to it, really. So I think the data set's called datasdv1.csv. Do that. Let's see, file does not exist. Oh, that's fun. Okay, let's see what it actually is called. There we go. Okay. So yeah, that should be what happens. This error is fine, don't need to worry about it. And then if you just type traffic data, I'll do .head, should be able to see that it loaded incorrectly, right? We have different rows, we have our columns that are labeled properly, and then we have all of our data loaded in. So yeah, once we do that, we can also look at like the end of the data so we can see just how extensive it is. Okay, so there's 60,000 rows, it looks like. I was completely wrong with the over 100,000, but still 60,000 police reports is pretty impressive, honestly. And we can also get some other information out of this. So we can see some basic table info and rows and calls, and then we can do traffic data shape. We want to print this information. See, okay, so there's this many rows and then there's 16 columns. We can also see what types of data there are. So traffic data dot types, dtypes, and we can see, okay, so each of these columns, what kind of information is stored in it. So you can see that injuries and deaths are all stored as integers. Everything else is stored as an object. So I think these are mostly strings, as it looks like here. They just labeled it as an object. So yeah, we don't need all this information. So the next step is actually start to clean up this data a little bit. And we can do that with using .drop, which is a built-in pandas tool that lets you drop columns from your data frame. So in this case, I think the only information we really need to keep is the police beat and the injuries, right? Because all we really need to worry about is where it happened and then how many injuries and deaths there are if we want to figure out exactly like what area is the most dangerous. If you're trying to solve a different problem, you might need to use different information, or if you want to like find more specifics, like maybe what streets these accidents happened on, or exactly like what kind of, you know, I guess crime occurred, you can use this charge description data. For this case, we're just going to be using the location, the number of injuries, and the number of deaths. So I'm going to quickly type this all out. It's a bit of a lengthy process to drop columns, but just bear with me for a second. So you're passing a list as a parameter, and inside the list, you'll name all the columns you want to drop. So port ID, want to drop, that's all I want to do. Port ID, date, time. Yeah, I'm not going to say this all out, but if you guys have any questions, by the way, feel free to let me know. I know pandas is a little confusing, especially like as a beginner. Even as someone who's worked with pandas a decent amount, it's not the most intuitive thing to use. Type to that. Yeah, I know this is kind of boring. That's part of the data science process, is going through the boring stuff. But you know, in the end, you get some interesting results, so kind of pays off. In the meantime, do we follow along with the exact same data set, or can we practice on another? Feel free to go on a practice on another if you'd like. I'm just going to be walking through this data set and like how I would look at this. But if you want to look at another data set, feel free to do that. And you can probably follow a lot of the same steps as what I do to look at that data as well. Just name SFX intersecting. Yeah, no problem. Now, while I'm doing this, curious, like, are you guys all done with midterms? Anyone still going through exam season? Two more midterms. Yikes. Yeah, Henry, I'm not looking forward to that quiz. I just started on the project, actually. I was using pandas for the project, believe it or not. But it does not seem fun. PA is going, it's going all right. I I found a repository that like kind of helped me understand how to do decision trees in Python, but yeah, still kind of confusing. And then drop hit run level. The programming assignment, William, for 151A. Are you in 151A? Oh, I didn't even know. Yeah, we have, I think our PA's due Sunday, but I don't know if you finished that already. Did I make a typo? What does it say? Key error not found in axis. Where did I mess up? Oh, axis equals 1. That's what I forgot. Yeah, they moved the deadline to Sunday, thankfully. Looks like we're all on 151A here. All right, so now hopefully if we load in this data frame or if you print it out, should see, okay, now all we have is the police beat, the injuries, and the deaths. So links to the slides, yes. HTTPS, hcm.url.com/hack.py5. That link should work. But yeah, for this workshop, we're mainly just going to be doing live coding. Feel free to look at the slides for some basic steps, but for the most part, we'll be doing this live in Jupyter Notebooks. Cool. So now the next thing we can do is we can actually look at the police beats, right? So we want to actually find out, okay, which communities did these numbers actually line up with? What was the second argument? Sorry about that. The second argument is axis is equal to 1. So I think this clarifies that we are looking at the column specifically. Right, so if you go back to our data set before, we really want to figure out like, okay, well, we have this information about police beats, but how do we actually know what communities in San Diego these match up with? This is where the descriptions of the columns, the traffic collisions dictionary comes into play, because it gives us a direct link to the data for the police beats. And we can go take a look at this right here. Just copy this link, paste it in here. And you can see that there's a bunch of different information, code to neighborhood list. So that's really what we want to look at, right? We want to see which of these numbers match up with communities. So here in La Jolla, we got 124 is our police beat, Bay Park 116. All of these different communities in San Diego have a different ID associated with them. And they don't list these neighborhoods in the data set, but we can actually use this data set to combine these two together and figure out exactly which police beat matches up to a specific neighborhood. So just like before, we'll download the CSV. I'm going to move it into the directory that we're working in. And then we'll want to load in that file into pandas as well, into its own data frame. So I'm going to copy the name of this, go back to Jupyter Notebooks, and then I'm going to make a new variable. I'll call it police beats. pd.read CSV, pass in the name. And then now if we do police beats.head, there you go. Now we can see that we've loaded in the numerical identifier and then its corresponding neighborhood. The next step is we have to actually figure out how do we combine these two data sets? How do we put this into just one data set where we can figure out the neighborhood, the injuries, and the deaths in that neighborhood corresponding to one another? So I'm going to make a new variable and I'll call it traffic data clean, or I guess maybe a better word would be combined, right? And we can use the .merge command, or sorry, method in pandas. And what this does is it's used to merge two data frames. This part's going to be a little confusing, so bear with me a little bit. Pandas is not the most intuitive when it comes to dealing with data sometimes, but yeah, I'm going to walk through this. So anyway, go back to our traffic data modified. We want to copy this, copy that, because that's the first data set we're going to work with, right? And we also want to combine it with the police beats data set. So those are our first two parameters. And then we're going to combine it on the left side of our, we're going to make a new data set with the left side being police beats, where we're combining it on. And the right side would be the beat. So this basically what we're saying right here is, okay, the police beat right here for this data set matches up with the beat right here in this other data set. We're telling pandas that we want to combine on these columns. So when you do that, I think got multiple values. Wait, what? Traffic data modified. Did I spell something wrong? Merge got multiple values for argument lefts. Oh, oops, sorry. Left on and right on. That's the correct way to do this. So now if we print out traffic data combined.head, you can see now we have the police beats and the beats in one data frame, but we're not quite done yet. So now you can see these beats match up, but we still have these two columns and we have a bunch of extra information that we don't need. All we really want is to keep the injuries, the number of people that were killed, and then the neighborhood itself. So we go back to this row, and now we can drop some extra columns we don't need. So we don't need the identifiers anymore, right? Because all we really need is the name of the neighborhood. So let's go back. We'll make a list as a parameter, and we'll pass in the police beat column name, and then we'll also pass in the neighborhood. So now if we do that, what did I do wrong? Police beat, neighborhood not found in axis. Did I spell something wrong? Oh, you know what? It's because I forgot axis again. That makes sense. There we go. So now, do this again. Now we have this. And then just for clarity, oh wait, no, I meant to drop beat, right? I want to keep the neighborhood. Cool. So I have this, and then just for clarity, I'm going to do some renaming as well. With pandas, you can rename your columns by doing .rename. So as you can see, it's actually really easy to just like chain together these methods in one line, right? Because every time you do merge or .drop, it returns a data frame itself, and you're able to call any of these methods on a data frame. So it's pretty easy just to chain these together in one line. Although maybe not the best for clarity, it does work. So in this case, we want to rename our columns. Doing index equals str just clarifies that we want to be renaming the columns, I believe, and then pass in columns. I want to rename neighborhood to districts. Cool. And now we can see, have all our corresponding neighborhoods and with the injuries and deaths. So now we still have the same amount of data basically as before. Now it corresponded with the district itself. And I think if it doesn't correspond with the district, it's dropped from the data set. So as you can see, we have some less rows than we had before because I think Pandas was not able to merge every single one, but we're just going to work with the data we have right now. Also, does anyone have any questions before I go forward? Okay, so yeah, if you guys have any questions, just feel free to ask as I go along. But yeah, now we have all this information, right? But we still have 27,000 rows. So what can we really draw from this? One thing that we can do now is we can actually find the mean number of injuries and deaths in each district. And we can do that pretty easily with pandas. So we're going to make a new data frame. We're going to call it traffic stats. And what we can do is we can take our combined data set and we can group by district, right? So if we do district, what this does here is it gives me an error, of course. Group by district, yeah. Traffic stats.head. Now you can see that the districts are grouped together, and you want to aggregate them by their means. So another cool pandas trick, but now what we can see is we have a lot less, much less rows. We only have 125 rows. And now we have the district corresponding with the number of mean injuries and the number of mean deaths. And this is not sorted right now, but you can see for each accident reported, these are the means in each neighborhood. So looks like these numbers are actually somewhat high. It looks like most of this data in this data set is usually from an accident that resulted in some sort of injury. But it looks like a lot less neighborhoods have deaths involved, which I guess is a pretty good sign. Yeah, so now that we have all this data, let me go back to our slide for a sec. We want to actually create visualizations and draw some conclusions. So I wrote 5 striked out right now because we're not going to be doing any modeling or machine learning predictions. We're just going to be doing some visualizations to get a better idea of what this data looks like. So Pandas also has some really good libraries for doing bar charts, or not libraries, some methods for doing bar charts. So what we can do is we can take this data and start off with, we want to figure out which neighborhoods have the highest number of injuries and the highest number of deaths. So we could start off by sorting values. And what we want to sort first is the mean number of injuries. So injured. The syntax is a little weird. So it's inside of this, there's a list as the first parameter. Inside of the list, you pass in a tuple, or I guess a set, with the number of people injured and then the mean. So if we do this, and we also do it descending, so we want to say ascending is equal to false. I can't spell, obviously. Now we can see which areas have the most number of injuries on average. So it looks like Sorrento Valley has the highest number of injuries per report, followed by San Pascal, Scripps Ranch. I really hope I didn't butcher that town name. I don't know San Diego very well, but anyway, what we want to do is now we want to keep sorting this data a little bit more, and let's create a bar chart out of it. So we're going to go up to the top 20 towns, or because I think there's a few hundred areas in San Diego. We're just going to take the top 20 of these, and we're going to plot. So like I said before, this all returns a data frame. This is a data frame right here. And Pandas allows you to plot data frames. What kind of diagram do you want to create? We want to create a bar chart. So we specify that we're creating a bar chart, and then whether or not stacked. So essentially what stacked does is it allow you to stack on top of the mean number of injuries, how many deaths there were as well. So we'll do that by saying true. We want the width to be 1, so this just shows how wide the bars are going to be. How wide the bars are going to be, and then the size of this actual bar chart. And this is a bit finicky. You can mess around with this yourself if you're working with your own data, but I'm just going to set it to be this width and height. And now if we do this, it takes a minute, but here you go. We've sorted all of the districts by their injuries, and you can see here that it looks like the district with the most number of injuries is Sorrento Valley on average. So there you go. And it looks like there's a lot of average deaths in Miramar Ranch North. So even though this isn't the top one, because this orange part's the highest, it means that the number of deaths in this area is actually pretty high on average compared to the rest of these areas. Another thing we could find out is what areas have the highest number of reports, for example. So this means like, where do police go to the most? Where do they collect most of this data from? I guess what people commit the most crimes, or not what people, but what area has people committing the most crimes regarding traffic accidents. So we can also do this by doing another kind of bar chart, and I'll do this pretty quick. We're going to save it as a bar plot. Go back to our clean traffic data, and we're going to get the district. We want to find the value counts. So what we want to do is we want to find just how many of these reports were made, and that's what value counts gives us. Like before, we're only going to take the top 20 districts. So what this does is it will index up to the first 20, and this still returns a data frame, so you can plot what kind. Like I said before, it's going to be a bar chart. What size? We're just going to match the same size before. And what color map are you going to use? So this is just for coloring. You don't really have to worry about this that much, but I'm going to go with this color set. And then before we actually do that, we want to set our labels. So you can set labels in a bar chart. What this does, it doesn't return a data frame, it returns a bar chart. But with that, you're actually able to call methods on this. So you could set the X label for the X-axis to be equal to districts. And then we can also set the Y label to be reports. So now if we do this, we get an error because I spelled something wrong. Oh, not cleaned, sorry. Traffic data combined, right. Cool, so this actually answers our hypothesis we had before. So our idea was that South San Diego would have the most number of reports or the most number of accidents. But it actually looks like Pacific Beach has the most number by a significant amount, which makes sense logically, right? Because Pacific Beach is, the big party area in San Diego. So it kind of makes sense that there'd be a lot of crime here, I guess, in general regarding traffic accidents. Probably like DUIs, stuff like that. I was in PB a few months ago. I saw someone get handcuffed and pushed onto a car. So that was an interesting experience. But yeah, I guess being in my third year at UCSC, I'm not super surprised it's PB now. Followed by North Park, Kearny Mesa, Mira Mesa, La Jolla, actually. I was surprised to see La Jolla so far up here because I kind of figured La Jolla is like kind of, an area where people wouldn't commit too much crime, but here you go. Now it's in the top 5, surprisingly. And yeah, if you guys want to take a closer look at this, you can do it yourself. But these are mainly the most populated areas in San Diego. And I think when I actually first looked at this data set a few years ago, Ocean Beach was a lot higher up than it is now. I think it was actually the second one. But it looks like, I guess, with more of the 2018, 2019, 2020 data, North Park has taken over for that second place spot. And yeah, we can actually also chart out the average number of injuries, for example, for not each district, but just like in general per report, how many injuries there were. So we can create a histogram for that. It's another kind of chart you can do. We're just going to call this hist, and we'll go back to our combined data set. I'm just going to copy this because we're still going to be using this, except instead of indexing by the district, we want to index by.
I didn't get that.
Siri just went off for some reason. I'm going to index by the number of injured. And then we're going to create a histogram. And what we're going to do with the histogram is we're going to actually bin the number of injuries. So as you can see in the data set before, like most of these accident reports only have like 1 or 0 injuries. But we can actually bin each of these into, I guess, different like bars, I suppose. So 1 bar would be like for 0 injuries, 1 bar would be for like 1 injury, 2, 3, 4, so on and so forth. So we can visualize that by using bin as a parameter to your histogram. And we'll pass in a list. We want to bin 0, 1, 2, 3, 4, and we'll say 5 injuries for the reports. And we want to see how many reports fall into these bins. So if we do this, get an error like every time I do this. Oh, we got something, but this is not what I wanted to see. I also spelled this wrong. It's bins. Bin is a reserved keyword in Python. So yeah, we can actually see, okay, this actually gives us all the information you really need, right? So most of these reports, it looks like almost all of them, because we have about 16,000 reports, have 0 injuries, which is good to know. But pretty significant amount have 1 injury. A lot have, I guess not too much, have 2 injuries, less have 3, 4, and then barely any have 5 injuries. But it's interesting to see because you can actually see how many of these reports actually result in someone being hurt. So even though it looks like, PB is a pretty dangerous area from this chart, in most cases, these reports don't actually have an injury. There's not actually someone getting hurt. But yeah, so you can also do some more stuff with this. So like I showed before, you can set labels. So for example, we limit this from 0 to 5, but like, what if you want to get rid of this little like left part we don't really want? What we can do is we can set an X delimiter, 0 to 5. So what this does is it will just shorten our charts so it isn't really too dirty looking anymore. We can also set labels. So we can do like set X label, do injuries. All right, and then we can also set the Y label as well. There you go. So these are just a few charts you can make. I think bar charts and histograms are very useful tools. But yeah, I think this is really all the conclusions that I drew from this data set myself. I'm sure you guys could also draw other conclusions based off of the other information, like what kind of reports there are. I'm personally curious about like what kind of accidents occurred the most. Like it looks like from the data set we looked at before, some of them are like DUIs, some of them are just like basic traffic accidents. So if someone want to take the time to look at actually like what kind of accidents happen the most, I think these chart descriptions are standardized. So you could actually just sort by these descriptions and then see exactly what kind of violations happen the most. But yeah, as you can see, there's a lot of different ways you can look at just one data set. And yeah, I think that really covers everything I wanted to go over in this workshop. But yeah, I guess I can kind of just conclude it right there. Appreciate you guys coming to this workshop. Looks like we had a kind of small group today, but I hope you all learned a little bit about Python and working with data. Data science is really cool. If you want to, draw conclusions from data, you can find a lot of really cool things. This is just one data set, but if you guys ever want to look at the San Diego data, there's, I think, over 100 data sets here on a wide variety of things you can look at. So if you ever want to have a little side project and look at, what kind of things go on in San Diego and what kind of conclusions you can draw, take a look at this. But yeah, thank you guys all for coming. If you guys have any questions too, feel free to ask. Thank you, Michael. Thank you, Thomas. Appreciate you guys all for being here. I know a lot of you guys had midterms this week, so it means a lot. Cool. Yeah, no problem, guys. All right. Catch you later.